Good morning, everybody. I want to thank all the powers that be, Steve and Carrie, Michael, Polk County, for having me come here. Yeah, it's tough. The tough part is I'm so excited to share so much with you in 45 minutes. So bear with me. I do have Kentucky lineage on both sides of my family, so I do like to talk. Everybody okay? Everybody can still hear me in the back? Good, because I just don't want to hold a microphone. Anyway, my name is Wright. I am the director of the Living Soil Compost Lab in Canton, South Dakota, which is just south of Sioux Falls. I used to live in Iowa. I used to live in Illinois. I was born in Indiana. I lived in Nebraska. I lived in Colorado, New Mexico, overseas. Done a lot of traveling in my life, all under the umbrella of agriculture. There's an old saying, those who can do and those who can't teach. I'm not a farmer. I don't even own an acre. But what I get the pleasure of doing is working with hundreds of thousands of acres a year as a soil testing, compost testing lab, as well as a consultant and really a teacher. So my background is in education. I've been a licensed educator for 17 years now. I've been teaching agriculture stuff, ecological agriculture stuff since 2012. So I've got a lot of experience. So as Jared said very brilliantly earlier, I'm no expert. I'm sage. I'm I am a shade tree at best, but I have a lot of experience. And my experience is largely staring down the microscope. A pair of binoculars with an Etch-a-Sketch is really what a microscope is. And a microscope is a tool. So it's something that I take onto farms and actively work with growers looking at their soils, their composts alike, and looking at what's there. Our lab specializes in bioassays. We do a biological analysis. We've helped Steve and Carrie with their product and their R&D that they've put in a lot of painstaking hours to improve their Johnson Sioux bioreactors, which, since I'm on camera, I will say and promote, you're making some of the most fungal stuff that we look at. So congratulations. Stick around this afternoon for the demonstration because they have dialed it in. The recipe, the procedure, and what we're doing with that is we're really changing a lot of farms. And so I've got a lot of experience at applying all these weird sort of alternatives to agriculture, actually to broad acres, to row crops, to orchards, to vineyards, to turf grass. I've got a very breadth of experience there that I'm happy to share. So I'm going to do a microscope demonstration today and hopefully have time to answer questions. We're going to look at a couple different samples and just get a visual aid, a comparison of the two worlds. I strongly promote agriculture practices that promote plant and soil simultaneously. We're very good at growing crops, and some of us are very good at growing animals, livestock. Hey, guess what? We're animals too. Plants, animals, that's 2 of the 5 kingdoms of life, the super kingdoms that all life forms fall into. Plants, animals. What about bacteria? What Jared was talking about. Fungi, okay, there's 2 more kingdoms. And what's that 5th kingdom? The protists, the protista, which are little microscopic multicellular organisms that eat things on the microscopic soil level. They're the coyotes, they're the foxes that are living in our soils, or we hope they're living in our soils, because they're eating all of the bunnies, which are the bacteria. Bacteria are everywhere. You could correct me, Jared, but I have never seen a dead soil. So for those of you in here who might be down on your luck and say, my soil's dead, I can show you something different by looking at it and showing you on the microscope. I could argue that it's not dead because bacteria are always going to find a way. When you have an organism that replicates every 15 to 20 minutes, they're going to mutate around whatever you're pummeling your system with. And that's not a judgmental statement either, because we are producers. We have to produce in order to have livelihood. I understand all of that. But commercial fertilizers, chemicals, they do have a collateral effect on the ecosystem. And I say that so with such fervor because I look at it through the microscope all the time. And I go onto people's farms and I show them on the microscope when we look at our in-row soil prior to an herbicide pass and then post-herbicide pass, and we see this bacterial bloom happen before our eyes. We've altered the ecosystem that's underneath our feet. So what we're trying to do is we're trying to deploy more organisms, more diversity into the landscape. It's very implicit in Ecology 101 that through diversity breeds resiliency. So like Jared said, the more diversity of organisms that we have in place in our soil, the more resilience that our system has. And we see healthier crops. And if we see healthier crops, if we have healthier crops, guess what? We're saving money because we're not applying that $20 passive insecticide through an airplane or through a highboy or whatever equipment. We don't have the operating costs to apply that fungicide because we have a healthier crop. My message is largely not yield. If you come to me speaking a yield language, I don't speak that language. I'm not an agronomist. I'm a folk agronomist at best. I could speak that chemistry language, but we're talking about profitability here. The opportunity here is profitability. When we arm our system with intelligent life forms that sort things out themselves, we are building that resiliency into our system again. I digress. There's so much I want to say, but thank you all for having me here. I'm going to get on the microscope and we're going to look at some stuff. And then those of you who've brought me these samples will have the context for what this is. Real quick, because there's always the newfangled words, you know, the sustainability, the regenerative words. I want to be kind of the first maybe to draw this connection. So I like this book a lot, Healing Adaptogens. It's a very digestible read for the human health side of things. So for those of you who want to know what people have been taking for thousands of years in other civilizations that increases their health and vitality and longevity, I would say this is a really good toe dip into that pool of understanding. We're talking about plants, mushrooms, things like that. These kingdoms that we're all talking about here have a very beneficial side for human health as well. But what defines something as being adaptogenic? There's three core principles to adaptogenic, something that is labeled as an adaptogen. Those three things would be, it's non-toxic, it's non-specific, and it's normalizing. I would liken that to a biological approach to your program. You're promoting something that's not targeted, but it is having a greater effect on the whole versus the sum of its parts. So adaptogenic agriculture could become a thing someday, I don't know. Also, fourth dimensional agriculture. When you're growing soil, you're growing time, right? Time being the fourth dimension. If you're growing time, you're growing harvests, right? So for the farmer-minded people in this room, the production-minded who are like, who is this whack job sitting in front of me talking about all this weird stuff? Think about it this way. Supplementing what you currently are doing, your conventional methods, supplementing it with biology. Supplementing it. Because with biology, you are growing time. You're planting a seed, and on that seed, you're planting the biology with the seed. And strategically, that's how we place these sorts of cultures, right? We're talking about people putting a pound of stuff per acre out there of a compost material, and they're just seeing the greatest results in the world. And for those of you who want to see the numbers on a screen or piece of paper, look up Dr. David Johnson's work on YouTube. A lot of it's right there, and you can see the value in putting just a couple pounds of ecological aerobic substrate, aka compost, out into the system at a rate of a couple pounds per acre is all. How do we do that? How do we deploy a couple pounds per acre? That's crazy. We wash it. We extract it. We've got a great example of that extractor sitting right out in our parking lot. We have a system that we can get that material into solution so that we can deploy it out into the landscape strategically on the seed, in the furrow, in the side dress as a foliar pass. It's non-targeted, it's non-specific, it's an adaptogenic approach. So it's something that we can really put out anytime. And guess what? If we're making it ourselves, what kind of cost do we have put into that? Our time, which is worth more than anything, because we have it, right, until we don't. But we have to understand that we have a huge opportunity here to create our own solution on our farm from our own waste materials. Value adding our waste streams and creating a compost, an aerobic compost culture, like Steve's going to demonstrate today, that we can then utilize and close our own loop. Become sustainable, you might say. We can close our own loop. And I have the very good fortune to work with a lot of producers who want to embrace that as well. And so it takes a little bit of retooling, and it takes a little bit of outside the box thinking and mind opening to this. But I will not promote throwing away with what you currently know. Do not change what is currently working for your farm. But if you would like to reduce your costs, we should talk. Because there's a lot of power that you can utilize from your own system. I digress because, again, there's so much I want to say. I need to get on the microscope. Is there any questions so far? Anybody? Call me crazy. Those of you in here who I've worked with who, yes, sir.
Maybe you could speak just a little bit more to the self-organizing that you touched on. We have all this microorganisms and biology. I mean, I know it's a big topic, but briefly maybe say something about the self-organizing.
The self-organizing, you mean harnessing the material from your own farm?
No, I mean, how does the biology self-organize? Maybe that's not really...
That's a question beyond my capabilities. I'm purely observing what is organizing in the microscope. And that's a tool that people just like you can actually take up on your farm as well. So as a trainer, as an educator, I teach people how to do that sort of observation themselves. But the organization, I don't know how it happens, but I'll tell you what one big key is oxygen. So when we're making these cultures of organisms, oxygen is paramount to what we're making. As long as we have oxygen, we are promoting realistically, 5 kingdoms of life at once. And so our solution becomes, instead of a single kingdom plant-centric approach, commercial fertilizers, grow that plant, get out of there, we're growing everything at once. And we kind of let nature take care of that. Now, through genomic testing, we can verify when we get our results back and we've got 25 pages of organisms we can't even pronounce. And a farmer says, well, Zach, what the heck do I do with that? I say, I don't know what you do with it, but you tell your buddy that you've got 560 fungi and see how many he's got if he wants to drop the coin on that kind of testing. You know, we have the testing abilities now that we can really verify the pure, just enormous diversity of what we're culturing on our own farms. I mean, it's very typical to see a DNA analysis come back with 500 kinds of bacteria plus. You buy a bug in the jug product, you might be getting 30. That's what the hefties are claiming. They might have 30 in their jug now, 30 species in their bug in the jug. Or there's other products out there that claim to have 80. And okay, but you have the opportunity to make hundreds of them on your farm. Not to mention, and I don't have the time to say enough about it, but the bigger organisms, the more megafauna, the protista, the nematodes, things like that, which are literally rungs of the food chain. You have the opportunity that you can grow those as well by simple composting. Go on to YouTube and just look up aerobic thermal composting or Johnson-Su composting and start there. That's a nickel's worth of free advice. Start there, because we as a testing lab, we get to look at a lot of people's stuff that watched the video and said, I don't know what the heck I just made. And then we help translate that for them. So the microscope is an old tool, but a very relevant tool for us to take a further look. And this really is a bottom-up approach. We're going to the bottom of the food chain because what Jared and I are talking about here exists at the bottom of the food chain. Okay, without them, we're not here. But we need them to fix more nutrients, to cycle more nutrients, better our soil health so that we have more time. Think about it. If we have more time, in the field because we're not in there controlling this pest, this fungus, that fungus. Doesn't that sound great to have more time? That can happen when we embed our systems with more microbiological diversity. And a Johnson-Su bioreactor composting method is worth your time to look into. There's other forms as well. Vermicomposting, another great composting form. Do you have a, I need a VGA. I've got a dongle somewhere. Take two to connect. I thought you had HDMI.
Yes.
Okay, thank you. Well, now that I've just vomited a bunch of energy on you guys, does anybody have any questions yet? Okay, so first things first, I have field soil that was brought to me by Steve. And Steve, would you provide some context of this soil? What do you know?
All I know is from my neighbor's field, this conventional ag, it's in a cornfield right now.
Okay.
Went in and without permission, scooped up.
Do they cover crop?
No,
Do they till?
I'm sure they do.
Okay. How's the corn look?
Good?
Okay. Tasseling?
Not yet.
Okay. We've had a lot of rain in South Dakota, so I'm impressed by, even though you've had a lot of rain here, you haven't had a lot of rain compared to us, because our corn is about waist high, and stuff is really looking good here. Okay, so we have conventional field soil. And this is a 1 to 20 dilution for you microscopists in the house. So I'm taking literally 1 cc of this soil and I'm diluting it with 20 cc's of distilled water. And so that gives me a dilution of a 1 to 20. This is a light microscope right here. And so our first magnification is 40 times the naked eye. Okay? So right away I see organic matter. Right here, this is what organic matter aggregation looks like. Now, one of my favorite things in the whole wide world to study and learn about and try to understand is something called humus. Now, I might have read this a long time ago. I don't know if I'm quoting somebody. If I am, it's on camera. I'll give credit where credit's due. But my best explanation for what humus is, other than it's the goal of what we should be trying to build in our growing systems, humus is the artifact of biological function. So humus is actually organic matter. It's a very complex bond of carbon, hydrogen, oxygen, and nitrogen that's packed together. It's been decomposed, and via microbes, it's been recomposed into greater and greater bonds. Those greater bonds being fulvic acid, humic acid, humin, H-U-M-I-N. Humin is an actual component. It's a humus substance. Now, humus is organic matter, but organic matter, which you're very used to seeing on your soil reports, OM percentage, is not humus. And so oftentimes we get soils with 7 and 8% organic matter in there. Another test that we also do in-house is we do a humus substance test. So we get a grade, essentially, for the soil, the compost, how well is it decomposed and humified. And just because that organic matter is through the roof, 7, 8%, long-term no-till, it doesn't necessarily mean it's humus. So humus is kind of this enigma in science that in some of the oldest scientific agricultural texts they were talking about. They were discussing, they were experimenting with, what is this black mold material? What is this humus all about? Well, the good news is when producers like yourselves go down this road and you start applying humus substances again, like compost, like organisms that make humus, because it's essentially digesting your soil, we see humus go up. And as we get closer to this aggregate, we'll be able to explore just via the screen and qualitatively, so just with our eyes, the quality of that organic matter. or humus. How well is it broken down? How well is it decomposed? And so I'll hone right in on that to begin with, because I like to see that right away. Oftentimes with production soils, we see none of this type of material. We see no organic matter aggregation whatsoever. And so right away, I'm seeing nice dark color, which would be loosely indicative of more of your fulvic and humic acids. Anybody in here, raise your hand if you use fulvic and humic acids currently. Okay, a couple of you, good, bless you. That's carbon. It's also, you know, especially fulvic acids can be kind of expensive. What if I told you you could make it yourself? What if I told you that as another byproduct of biological stewardship, planting microbes back into your soil, you could make humus happen right there in your field, because the organisms are digesting the organic matter and recomposing it into more and more stable structures. And you might say, well, how long is that going to last in my soil? So I would, oh, there's a flagellate that just rolled by. So you would say, how long is that going to last in my soil? Well, depending on the level of disturbance that happens in the ecosystem, that's going to be there for greater than 500 years, because the half-life of humic acids is greater than 500 years. We're talking about a long game approach, not just a crop this year, we'll do it again next year. We're talking about investing not only in the crop, but in the soil at the same time, because there is a possibility here, and I've seen it, and I would like to inspire you thinking about this. You could actually plant physically in better soil next year if you start supplementing with a biological functioning component into your growing system again. So anyway, this soil is, we're now at 400 times the naked eye. So we've got a lot of bacteria. And what we would call in the soil food web world, we would have already, I could tell you, a bacterially dominant soil. Now we do an assay where we do count, we measure, we have numbers on a piece of paper for you to give you a fungal to bacterial ratio. But this right here, already I can tell you from experience that this is a bacterially dominant soil. And through soil food web theory, developed by Dr. Elaine Ingham largely, we would deem a bacterially dominated soil as being a soil that promotes what? Weeds, exactly. Nitrate-loving, pulsing, early successional weeds. So in time, as we deploy more of the organisms that eat the organisms and more of the fungal component, which is the other half of the bottom of the food chain, next to bacteria, as we deploy more of that diversity overall into the system, we start to I would say evolve our form of nitrogen out of a nitrate form into a more of a plant promoting form as ammonium, more of a stable form called ammonium. And we see a reduction in weed pressures. Not an obliteration of weeds, that's not going to happen. But we do see a reduction in weed pressures. And in fact, where I've worked with people 6-7 years now, we see almost a successional shift of weeds. So their dominant weeds each year change because they are starting to deploy more of a diversity into their system and grow the whole system and not just the crop. So because I am already running out of time, I told you 45 minutes. I mean, I've done 5-day things of these. So, yeah, I mean, can you imagine? Yes, sir.
When you're back to the screen, a couple of guys swam across the screen.
So those would have been flagellates. Those are the fifth kingdom. That's the protista that are swimming around there. Believe it or not, those things, those are the foxes. Those are after bacteria. And when they eat bacteria, they release all of the wonderful nutrients that those bacteria have immobilized in their little bodies. But without those predators in the system, no wonder we need commercial fertilizers, right? So predatory organisms like that, and your nematodes, your beneficial nematodes, which we culture very naturally through aerobic composting, those also belong in the system because they're cycling nutrients too. Okay, So I don't want to spend a whole lot of time here, but I see decent organic matter, believe it or not. I'm surprised he tills, or she, sorry. I'm surprised they till. Judging by the organic matter looks good. Do they spread manure, do you know, Steve?
I don't know.
Okay. So manure can definitely add to the organic matter component and can contribute some of these humus substances that we're just seeing on the screen. These big dark aggregates, that's an air bubble, folks. There's another air bubble. But again, if I go up to 400 times the naked eye, we're seeing mineral component. That's your parent material. This would be a silty soil just by observation. Right there we have a little tiny segment of fungi. Right there. Now generally speaking, when fungi lacks pigmentation like that and it lacks cross walls, we deem it as an oomycete, which an oomycete is another fancy way of saying water mold. And these are the type of funguses that can often be very pathogenic in our soils. So with the presence of this type of fungi, and if I were to do a full analysis and not see any more beneficial type of fungi, which would have color in this hypha, this thread right here is the actual growing fungus. If I were to see pigment and cross walls where it would look like bamboo, without the presence of that and only this, I would say this has a fungal pressure to this soil. And I would advise the grower, you probably want to have some sort of a remediation strategy on board. Some sort of fungicide or a natural fungicide. I like using lactobacillus bacteria as a natural fungicide, which is like the bacteria that essentially make cheese. So yeah, seeing just very bacterially dominant mineral, high mineral, low OM soil. I would venture to guess this is under 3% organic matter just through experience and guessing. But flipping over now to what we are putting out into soils like this. So this would be Midwest Soil Restore compost that we are using as little as 1/10 of a pound per acre in some operations. And then I don't know what your highest induction rate is of what somebody's using this as. 2 pounds. So 2 pounds of this material washed into an extract, literally like this, filtered out, 50 mesh. For those of you in here who wonder what is my filter screen size, 50 mesh, 30 would be even better, but 50. And then that's literally what they're putting into their soils. So again, same dilution as before, 1 to 20. There's just so much. I'm so sorry if this has been all over the place. I even had a PowerPoint presentation I can't even get my words, but made, and I just scratched it because I want to try to spend as much time on here as possible. So this now is an aerobic compost culture that we would use, again, on our seed. We'd seed treat with this stuff, about 2 to 4 ounces per hundredweight, kind of the industry standard. So in other words, about a 5-gallon pail of taking this type of material, bubbling it, making a slurry out of it, will treat about a pro box of seed. And how do we know we did a good job of treating? Because we've done enough field checking where we've reached into that pro box, we've grabbed a random seed that we've treated, we've put it in here, we've rinsed it, and we've put a drop on the microscope, and we've seen the physical fungal spores and even organisms on that seed. And I've had a lot of farmers over the years that send me treated and untreated, completely disguised. I have no idea which is which, and I land it every time because that thing doesn't lie. The microscope does not lie. It's just an observation tool.
A pro box, you mean like a tote that does 40 acres of soybeans, for example?
I guess it's 40 acres. Yep. Yeah, one of those great big black plastic tote boxes. But with like 3.5, 4 gallons of solution is all. So already, now I'm at 100 times the naked eye. This is where compost cultures can really shine, and the Johnson-Su method really shines. And Midwest Soil Restore's culture that they make really shines. See all these black dots? Say that louder. Who said that?
Spores.
That's right, fungal spores. That is baby fungi that has been now, it's been reproduced, it's preserved itself. And what's nice about this form of fungi versus the hypha itself is these little things fit through about every screen you can throw in front of it. That's why this is such a good method for creating a very repeatable, good culture. And we're seeing such dramatic effects out into the landscape. Again, look up Dr. David Johnson to see his research. These fungal spores make it through every type of screen. And that's largely what you end up with a mature bioreactor. An aerobic thermal composting method, so a method you're using temperatures and you're turning it, you're kind of married to this pile for about 30 days. We also achieve this level of spores as well. It takes oxygen to achieve that level of spores. This thing right here, that's another one of those protista I was talking about earlier. That's an amoeba called a testate amoeba. It's like a microscopic snail, and that's like a wolf. A very slow wolf, but that thing right there is going to eat a lot of bacteria, and it's going to release a lot of those nutrients into the rhizosphere of the plant in a plant available form. A lot of nitrogen. Not to mention any other microminerals, nutrients that those bacteria have etched off of the parent material. It's going to release that up the food chain as well. So already at 100x, we can't even count the spores. I mean, we could, but it's going to take a while, folks. We probably want to dilute it a few more times. But then I go up to 400. And we see bacteria. Those smallest dots kind of floating around there are bacteria or clay particles as well. So when we're counting bacteria, we have to dilute the crap out of this in order to really differentiate between bacteria that are moving independently and that are clay particles or any other sort of detritus that's just that small. That's a mineral right there. Here we have more of these humus substances, as I call them, that are starting to form this kind of yellowish gold brown. Your fulvic acids, your humic acids. But as I cruise around here, I mean, the amount of spores is just incredible. We do a very brief spore assay when we do our formal assay. And essentially, we're looking for a spore every field of view. If we see a single spore per every time we stop the microscope, we call it, at 0 to 100%, depending on how many fields that we land on. And stuff like this, we see so many spores in every field. We're well over, we're at full 100%, what I would deem as a fungal colonized material. I've looked at a lot of Johnson-Su bioreactors from the lower 48 states now. Jay Young on YouTube has really helped a lot of people send their material to us because, again, they watched the video and they said, I don't know what the heck I just made. And I'll tell you this, people are dialing it in. I mean, they're not the only ones that are creating this level of culture. Steve's making arguably the highest fungal that we've seen, but people are getting close to it, and they're just watching a video and putting the ingredients together, and they're maintaining the moisture. They're following the procedure. Another amoeba right there. Again, that is an organism about the second rung of the food chain that's going to eat the bottom of the food chain and cycle those nutrients up. In most of our production systems where we have, again, gone more, of a commercial fertilizer route or more of an allelopathic, fungicidal, insecticidal, a targeted route, we've had collateral damage, unfortunately, and these things have gone by. We don't have the predators in the system anymore. So our bacteria are holding all the cards. They're the little bags of fertilizer that we can open up via more diversity. And yes, the only way we can know it is really look at it. And I'm happy to discuss with any of you who wants to learn how to use a microscope or be your microscopist. So it's your decision.
Zach,
yes, sir.
For clarity, is the brown dots, that's the spores?
These are the fungal spores, yes. And so you have kind of an oblong football shaped, you have a spherical spore, some spores organize in clusters and triads. There's all different, fungi is so diverse. But that color that you see in the spores themselves is created by melanin, just like our skin. So they're very similar to us. Fungus, the fungal kingdom is more similar to animals than they are plants.
That is almost exactly 1 year old.
Big piece of organic matter right there. So right here, where you still see cellular structure, that's what I would deem as is more immature organic matter that is yet to be humified and packaged and broken down, because you can still see the structure of that material in the microscope. So if I were to receive this in the office, I would do my assay. In my comment section, I would note this is still has a little ways to go in terms of maturity. From a fully mature compost, we would not see this type of raw organic matter left in it.
Would that maybe be some wood chips?
That'd largely be from the wood chips, because bacteria can't break down things like wood chips and a lot of your hemicellulosic material from your crop residues, your trash. It takes fungi to do that, which is another reason why fungi is so important. Mycorrhiza is great. It's a symbiotic fungi. Put it on your seed. I mean, I could talk a lot about mycorrhiza fungi, but saprophytic fungi, which is what we largely grow in a compost pile, that's your decomposing fungi. The soil is the gut that covers all the land on our earth. It should digest. And to quote Chris Trump from Korean natural farming fame, when he came to Iowa about 4 years ago in Newton, we did a field grower meeting day, and he, first thing out of his mouth, he said, everybody here, who here knows what a fecal transplant is? And myself and maybe another person were the only ones that knew what that was. And he said, well, we're going to give your soil a fecal transplant, because he was talking about biology. And then he went on to say, because the soils here are largely constipated. And I would echo that analogy as well. Because we have not looked after the ecosystem at the bottom of the food chain, we have a dysfunctional system, a system that can't digest itself. Now, don't hang your heads. Don't, that haven't started or like, I'm not getting there. The good news is these biological applications are non-leachable. They will not volatilize and rinse out of your soil like a commercial fertilizer is, because they're little carbon creatures. And they're also bound to carbon. That's what holds on to it. Then it becomes a game of managing disturbance.
Would it be time to show a slide of the regenerative soil?
Yeah.
Zach, you want to open it up for questions? See if people have some thoughts that they want to.
Yes, fire away, anybody.
So do the fungi sort of die at the end of their life cycle, and then the spores are what they left behind, or do they become spores when they get hungry and eat?
When they run out of food, they preserve themselves and they create spores. And a lot of times you see those fruiting bodies called mushrooms that they develop their spores from talk about an uncountable amount. The amount of spores that come out of a single cap of fungus or mushrooms is just insane. But yeah, essentially, when this material runs out of its carbon resource, what you're left with is largely fungal spores. And according to Dr. David Johnson directly, he said in his finished Johnson Suit compost, he really only sees fungal spores because everything else has gone into a cyst form. Everything else has kind of gone to sleep because the food resource is gone. So this is regenerative soil. Would anybody that knows what they brought, Michael, would you provide context, or the grower? Caleb.
It's an organic farm for sunflowers last year, and we got that last week.
Okay. And you guys do a lot of composting.
Yeah.
So,
Had Johnson Zoo on in furrow when we planted the sunflowers. And this spring before the sunflowers, there was a wheat rye cover crop that got moldboarded down.
wow,
And then chicken litter spread on
great humus.
over the winter.
Oh, got a nematode. So this is about the third rung of the food chain here. That is a nematode. And you'll see it move. So imagine that thing trucking through the soil. I mean, on a physical level, you can kind of see how if we only have bacteria, oftentimes it's very compressed, compacted soil. But if we start trucking these larger organisms through the soil, we're physically opening up the soil kind of like a worm does and creates its middens on the surface that we can see. We see these little organisms, and you'll see protists zoom through here. I mean, they're opening up the soil for more oxygen. And if we have more oxygen, we have more root depth, more root growth. So oxygen is hugely gained through a biological component in your system. How did your sunflowers do, Caleb?
Good.
How many tons of compost did you spread?
2 tons of raw chicken litter over the winter of the week that we just harvested it. We just put a couple tons of that compost, wood chip-based compost going into the sunflower.
Okay.
No litter.
That's a fungus.
Zach, is there something between this sort of regenerative soil and the other soil that you're seeing that's different, that's unique, that you can sort of point out to the folks here?
More of a fungal component for sure. As far as the diversity of fungi, it's too early to tell. So oftentimes when we do have like a pathogenic fungal pressure, it is almost the exclusive fungi in that soil. We don't really see much for diversity. So if I had more time and could scan the whole sample, I could uncover whether or not we see more kinds. And the fungus is in all different shades of color, sizes, widths. So that does kind of, that morphology, the shape and the color, does indicate diversity overall, but I can tell you applied a lot of chicken litter. So chicken litter is very bacterial, very high nitrate bacterial. And one last story that I'll leave with, I was down in the largest ag show in the Caribbean last fall, in August actually, in Jamaica. And I was on the radio, they advertised me on the radio as a soil doctor. I'm not a doctor. I don't claim to be a doctor. I'm shade tree at best. But anyway, so all of a sudden, I'm at this 3-day ag show and I have farmers lined up with their bags of soil because on that little island, there's over 100,000 farmers. And I looked at so much Jamaican soil in 3 days, and their program is largely chicken litter. Believe it or not, they're one of the largest chicken producing places on earth. They love their chicken. And they grow a lot of chicken and create a lot of chicken poop. And so most people, their fertilizer program is chicken litter. And so I'm in kind of a building like this, and we got 2 big screens in the microscope, and we're just seeing samples, bacterial after bacterial. But what I started to notice was some of these samples had fungi in it. Some of these samples actually had protozoa. By day 2, I pretty much figured it out. These farmers were not using chicken litter, but they were using sheep and goat litter. Now think about it. Those animals have a completely different ration, and their ration is more fungal. So for those of you who have contact with sheep producers, goat producers, llama producers, get their manure and make compost out of it, because it's naturally, because they just have a more, I would say, an herbaceous diet versus more grain-fed, they have more fungal component embedded in the manure itself. And so the takeaway was, wow, you guys need to use more goat manure with your chicken manure maybe to increase your overall diversity because you're just bacterial.
Zach, we need to take a break here. But
Yeah, I'm sorry.
Any questions that you want to ask Zach? Right, we have time for maybe a couple of questions, and then we'll take a quick break, and then we'll move on. Any thoughts from the audience? Zach, we'll be around this afternoon, so you can talk. Go ahead.
I wondered about the role of salt in the bio of all these critters, in the soil. As we were part of the Pangea, we had this whole salt sea, and now we end up with high concentrations of sodium or calcium or potassium. Does that throw off the balance and kill a lot of these critters, or does it add to the system?
So I like sodium. I think some crops really do, like sunflowers, prefer a deal of sodium. Like they actually want more sodium. Some crops more than others. But think about it. These organisms, like us, are 80% water. And on a microscopic level, that salt is having a negative impact on their little bodies just like ours. And they don't have skeletons or exoskeletons, a lot of them. So they just fry. And so my observation after a lot of commercial fertilizer applications, the instant after the application, is there does seem to be this complete die-off of your larger organisms because of the salt component in that fertilizer. That electrical conductivity, you might say, that high salt solubility component does observably fry organisms. And when that happens, bacteria seem to mutate around it and they flourish. So I think salt has a huge component. But on a traditional chemistry test, you know, we're looking at the conductivity of the soil, we're looking at the sodium levels, we're looking at potassium, magnesium, and we're taking chloride, we're taking salt into consideration, for sure. But like with the extracts that we're applying, we don't apply the extracts with a high analysis commercial fertilizer. We can. Nicole Masters and some of the other experts say we can, but I don't recommend it. No, we use other amino-based forms of foods to put with the microbes instead of a very salty fertilizer. We do notice a big impact if our conductivity gets too hot on the total solution.